Hello, student, and welcome. Today, I want to take you through some calculations that involve moles. For instance, assume you're told to calculate the number of moles that are in 12 grams of magnesium. You're further given that magnesium has a relative atomic mass of 24. Now, what you can do, just pause the video and try to attempt the question. Good. After attempting the question, now I can show you how you go about that. The number of moles will always be given by the mass given divided by the molar mass. Remember, the molar mass of an element is basically the relative atomic mass expressed in grams. Therefore, for this question, it will be 12 grams, the mass that you're given, divided by the 24 grams per mole. That is the molar mass of magnesium. And with that, you get the answer to be 0.5 moles. What does that mean? Which means that 12 grams of magnesium is equivalent to 0.5 moles. Question 2. You're told to calculate the number of moles that is present in 24 grams of sodium hydroxide. You're further told that sodium has a relative atomic mass of 23, oxygen has a relative atomic mass of 16, and hydrogen has a relative atomic mass of 1. Again, you can pause the video and attempt the question. Okay, having attempted the question, the number of moles again is given by the mass divided by the molar mass. And when you talk about ionic compound, now the molar mass will be the relative atomic mass, or rather what you call the relative formula mass, that is expressed in grams. For sodium hydroxide, the molar mass will be determined by adding 23, 16, and 1. And then you get 40 grams per mole. That's the molar mass of sodium hydroxide. Now, going further to calculate the number of moles, it will be the 24 grams that you given divided by 40 grams per mole. And for that, you get 0.6 moles. That means 24 grams of sodium hydroxide is equivalent to 0.6 moles. Going further to question number 3, you're told to determine the number of moles present in 26 liters of oxygen gas. You're further given that the molar mass of any gas at room temperature and pressure is 24 liters. Remember, the molar mass of any gas, it is basically or what we are calling the molar gas volume, is basically the volume of 1 mole of the gas at the given condition. So what you need to do is to go ahead and argue out if 24 liters of oxygen is equivalent to 1 mole, what about 36 liters of oxygen? So it will be 36 liters multiplied by 1, then divided by 24 liters per mole. And with that, you get 1.5 moles. What does that mean? It means that 36 liters of oxygen contain an amount equivalent to 1.5 moles. Going further to question number 4, you're told to determine the number of moles present in 150 cubic centimeters of 0.4 molar sodium carbonate solution. So going further, how do you go about that? Remember, as I've been saying, you can pause the video and try the question before you follow what I'm about to do. With this one, I will go ahead to argue out if 1,000 centimeters cubed or cubic centimeters of this solution has 0.4 moles, what about 150? Therefore, it will be 150 cubic centimeter, you multiply by 4 moles divided by 1,000. Remember, you can decide to use the formula that the number of moles will be given by the volume that you given multiplied by the molarity divided by 1,000. If I go ahead to work out that, it will be 0.06 moles. What does that mean? 150 cubic centimeters over 0.4 molar sodium carbonate solution has 0.06 moles. Others, thank you for watching. Looking forward to posting more calculations. Thank you so much.